Every day, millions of cars burn fuel, releasing pollution and heating up the planet. Electric cars are growing fast, but they're not the only option. What if we had a fuel that refueled in minutes, emitted only water vapor, and ran on the most abundant element in the universe? I'm Vishnu Ashwat, and today we're breaking down the science of hydrogen-powered cars, how they work, why they matter, and how green hydrogen and government support could make them the future of clean transportation. Hydrogen fuel cell cars use hydrogen gas to create electricity in real time. Unlike gas engines that burn fuel or electric cars that store energy in batteries, hydrogen cars generate power through a chemical reaction inside a fuel cell. No combustion, no waiting, and no greenhouse gases. Just electricity and water vapor. In this video from Forest Auto Reviews, he is showing us what is it like to fill up a hydrogen car. It is just as simple and time efficient as it would be to fill up a gasoline-powered vehicle. Here's how the chemistry works. Hydrogen gas, H2, enters the anode of the fuel cell. It's split into protons and electrons. The electrons flow through a circuit, creating electricity, while the protons pass through a membrane to the cathode. There, they combine with oxygen for the air to form water. The full reaction is simple. 2H2 plus O2 2H2O plus energy. This is called a PEM, or proton exchange membrane fuel cell.
This process is clearly outlined in Chandon et al.'s 2018 article from Fuel Cells, From Fundamentals to Systems.
Hydrogen cars have big advantages. First, they refuel in under 5 minutes, faster than charging any EV. Second, they can drive over 300 miles on a tank, with no emissions except water vapor. Third, they are perfect for heavy-duty vehicles like buses and trucks where batteries fall short. AS Ball and Weeder State in Energy and Environmental Science, 2019. Hydrogen vehicles are just as efficient as battery EVs and better suited for long-range and heavy transport due to their quick fueling and energy density.
As Ball and Weeder State in Energy and Environmental Science, 2019. Hydrogen vehicles are just as efficient as battery EVs and better suited for long-range and heavy transport due to their quick fueling and energy density.
But hydrogen tech has some major roadblocks. First, it's expensive. Most hydrogen today is made from natural gas using a method called steam methane reforming, which still emits coal. And second, there just aren't many hydrogen refueling stations.
Producing hydrogen from water, electrolysis involves splitting water into hydrogen and oxygen with the help of electricity. When a direct current is passed through the water, oxygen appears at the positive anodes, while hydrogen is released from the negative cathodes. In terms of volume, exactly 2 times more hydrogen is produced than oxygen. As pure water is not a good conductor of electricity, something like salt is added, not a very environmentally sound method. If you use a proton exchange membrane, PEM for short, it is possible to extract hydrogen from pure water, as the membrane provides the necessary particle transport between anodes and cathodes. This same PEM technology is used in hydrogen fuel cell cars. Once the hydrogen is created, it's stored in tanks and later fed into a fuel cell, where the reverse of electrolysis occurs. Hydrogen combines with oxygen in the fuel cell, generating electricity to power the car, while the only emission is clean water vapor. So from production to performance, PEM electrolysis is key to making hydrogen-powered transportation truly sustainable.
Stafford I'll explain in Renewable and Sustainable Energy Reviews, 2016, that as renewable energy becomes cheaper, green hydrogen becomes scalable and sustainable for long-term energy storage and vehicle fuel.
This is where government steps in. Building green hydrogen infrastructure is expensive. That's why the US Department of Energy created the Hydrogen Shot, a plan to cut green hydrogen costs to $1 per kilogram by 2031 through funding and research incentives. According to Elgo Waney et al. In a UC Berkeley research paper, eScholarship, 2022, coordinated government policy can drive down hydrogen production costs by over 50% and fund the construction of national fueling networks.
In this video, US Senator Heinrich is discussing hydrogen cars as a potential replacement for gas-powered vehicles.
Hydrogen cars are already real. Models like the Toyota Mirai and Hyundai Nexo are on the roads in California and Japan. As stations expand and costs drop, these cars could become mainstream.
Let's review the chemistry. In a fuel cell, hydrogen is split into protons and electrons. Electrons create electricity. Protons combine with oxygen. The result: energy and water. It's clean, it's efficient, and it's chemistry doing all the work.
Hydrogen fuel cell vehicles aren't just efficient, they are futuristic. With ultra-fast refueling, zero emissions, and a clean energy source, they offer a bold vision beyond gas and lithium batteries. While high production cost and limited infrastructure pose challenges, cutting-edge science and forward-thinking policy are closing the gap. Powered by green hydrogen and innovation, these cars represent more than progress. They are the future of transportation, driving us toward the cleanest, smartest road ahead.
Thank you for watching my chemistry research project. I'm Vishnu Ashwath, and this is why hydrogen isn't the first element. It might be the next big one in transportation.